Hello guys, today we are going to talk about fractions. Then, fractions represent equal parts of a whole. In the graphic, in this picture, you can notice that the circle is divided in 8 equal parts. That's important for fractions. And also we can notice that 3 of these 8 parts are shaded. Then the fraction represented here is 3/8. At the bottom, the number of parts that is divide the circle, and at the top the number of the shaded parts. Okay, then let's talk about the types of fractions. The first type of fraction is the proper fraction. Proper fraction in the graphical way is when we use less than the unit to represent the fraction. Then for example here, remember, for example here is 3/8. That means that there are 3 shaded parts from a total of 8 parts. This is a proper fraction. Then in numbers also we can notice that the number at the top is less than the number at the bottom. That's a proper fraction. Okay, remember guys, the number at the top in here, in this one, in the example 3, it's the numerator, and the number at the bottom, in this case 8, is the denominator. The proper fraction, the numerator is less than the denominator. Then next type of fraction is the improper fraction. The improper fraction, it's a opposite definition for proper fraction. Then for improper fraction, the number at the top, the numerator, is greater than the number at the bottom. Then for example 5/3 is one example for improper fraction. Another one 6/4, for example. Okay, in a graphical way we can notice that improper fraction, or to represent a fraction, we have to use more than one unit. Here for example we have to use, or we used 3 circles in the first picture. Then 1, 2 and 3 is more than just one circle. That's why it's an improper. Now each circle is divided in 3 equal parts. Then that means that the number at the bottom, the denominator, is the number of the parts that you divide each circle or each unit, and the number at the top are the shaded 1, 2, 3, 4, 5, 6, 7. Then the fraction here is 7/3. As you can see, the numerator is greater than the denominator, and in the graphic representation we have to use more than one unit, 3 circles in this case. The second graphic, we have a square that is divided in 4 equal parts. Then how many parts? 4, that's the denominator. And how many of them unshaded? All of them in this case. Then 4/4. 4/4 is also an improper fraction because the numbers at the top and at the bottom, the numerator and the denominator, are equal, and also because we use, in the graphic representation, we use the whole unit. Then just when we use less than the unit, it's a proper. If we use the unit or more than the unit, it's an improper fraction. Okay, then let's conclude something important. Exist whole numbers and fractions. Whole numbers, for example 2 or 3 or 4 or more, or its opposite, -2, -3, -5, we call these integer numbers. But integer numbers are whole numbers too, because it's not part of the number, it's the whole number. Okay, the number complete. Fractions, for example, is can be 1/2 or 1/2, 1/3, or for example 8/5. Okay, we have many other options. They are parts of the number. There is not complete number, just part of them. Then exist also mixed numbers. Mixed numbers are numbers composed by part whole number and part fraction. Then for example, let's analyze the first graphic. We can see that we have 3 circles, 2 of them completely shaded, then the whole part is 2. And from the third one, just half part of the circle is shaded. Then the number represented here is 2 and 1/2. 1, 2, and 1/2. Or also you can say 2.5. That's the graphical representation. In the second one, the second picture, we have exactly the same image, but we divide each circle into equal parts. Then let's find the fraction here. Each circle is divided by 2, then 2 is the denominator, and shaded parts are 1, 2, 3, 4, and 5. Then in fraction way, this graphic representation is 5/2, and in a mixed number is 2 and 1/2. It's another way to represent numbers that are not complete, that are not whole numbers. Okay, then here now it's important to talk about how can we transform numbers from mixed numbers to fractions. Then it's really simple. Remember, this is the example before that I explained before, this one, the first picture. Then in here we can see that 2 units, 2 circles are completely shaded, and half part of the other one, then it's 2 and 1/2. Okay, in a fraction way, then we have to divide each circle exactly the same. The third circle is divided exactly in half part. Then we have to divide also all one exactly into equal parts. Now, if we divide in 2 parts all of them, then everybody knows that the denominator is the denominator is 2, not 4. The denominator is 2 because it's the number of parts in which we divide each circle. And the shaded numbers, the shaded parts, are the numerator, the 1, 2, 3, 4, and 5. Then in here, there's one way to transform from a mixed number to fraction number. Okay? Then, for example, let's analyze the second example, the second picture here. How many of these circles are completely shaded? Then 1, 2, 3, 4. 4 completely shaded. And from the fifth one, just 3 parts from 4. Then 3 from 4. Then the mixed number is 4 and 3/4. If we have to transform from this mixed number to fraction, then let's analyze that each circle is divided by 4. That means that is over 4. And let's count how many of these are shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Then the fraction is 19/4. Mixed number, fraction number. Obviously, math, arithmetic especially, allowed us to use a different strategy. Then let's use exactly the mixed number before. 4 and 3/4. Then by arithmetic way, we can also find a fraction. Then we have to multiply the whole number, in this case 4, and multiply by the number at the bottom in the fraction part. 4 times 4 is 16. And we have to add the number at the top of the fraction, 3 in this case, plus 3. And put it over the number at the bottom in the fraction part, in this case 4. 16 plus 3 is 19 and over 4. Then this is the mixed number, 4 and 3/4, and this is the fraction number. One more example. For example, 5 and 1/2. Then remember the strategy. We have to multiply the whole number, 5, times the denominator of the fraction part, then times 2. 5 times 2 is 10. And we have to add the numerator of the fraction part, in this case 1, then plus 1. And put all of these over the denominator of the fraction part, in this case 2. 10 plus 1 is 11, divided by 2 or over 2, then the fraction is 11/2. Mixed number 5.5 or 5 and 1/2, the fraction 11/2. Okay, now interesting also talk about the opposite way. transform from fraction to mixed number. Then, for example, in here, each circle is divided in 6 parts. Then the denominator of the fraction is 6. And how many of them are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19 parts. Then 19 over 6 is the fraction. Now, from a mixed number, we have to check how many of the units are completely shaded. Then 1, 2, 3. 3 are completely shaded, and from the fourth one, just one part of 6. Then fraction number, mixed number. Very simple. But obviously, arithmetic is also going to help us to find or to do it in an easier or faster way. Then, for example, let's analyze the fraction 5 over 2. If we have to transform 5 over 2 in a mixed number, we have to divide 5 divided by 2. Okay? Then 5 divided by 2 is 2. 2 times 2 is 4. Put it here and subtract. And 5 minus 4 is 1. Obviously, it's not possible to continue the division. Then that's why we have to put the decimal comma here, or the decimal point here, and continue the division. We put the decimal point, then we can put zeros in the remainder part. Then now 10 divided by 2 is 5, and 5 times 2 is 10. Put it here 10 and subtract. Now the remainder is 0. Then we can't continue the division. Then the answer is 2.5. It's a decimal number. Then we know that 2.5 means 2 complete number, and 0.5, that is 1/2. 0.5 is 1/2. Then 5 over 2 is exactly the same that 2 whole and 1/2 of the next unit. 1/2 is equal to 2.5. Okay? Now, let's talk about equivalent fractions. Equivalent fractions are in the number line. They are fractions that use, or they are exactly in the same position in the number line. Then, for example, let's plot the fraction 1/2 in this number line. Then 2 is the number of division that we have to do per unit. Then the first unit is from 0 to 1. Then let's divide into equal parts. Okay, now it's divided into equal parts. And the number at the top is the numbers, the section that we have to take. Then from 0, 1, here is 1. Okay, then here is 1.5. That's the position for 1.5. Now, with different color, let's plot this point. 2 over 4. Then 4 means the number of parts in which we have to divide the unit. Then the first unit is from 0 to 1. Then one more time, here is the first part, and now the half part and the half part. Now we divide the unit from 0 to 1 in 4 equal parts. Now how many parts we have to take? 2, according to the number at the bottom, at the top, in the fraction 2 over 4. Then let's start. 1, 2. Exactly in this position, the same position we have 2 over 4. That means, guys, that 1/2 is equal, or is equivalent to 2 over 4. These fractions are equivalent because in the number line they are located exactly in the same position. Okay, another definition for equivalent. Equivalent fractions are also fractions that we can simplify them, and they're exactly the same. Then, for example, let's analyze 10 over 4. If we simplify, remember that simplify means divide each part of the fraction. Then divide the numerator 10 and the denominator 4 by the same number. Then, for example, 10 divided by 2 is 5, and 4 divided by 2 is 2. Then the fraction now is 5 over 2. Then 10 over 4 is exactly the same that 5 over 2. That's why they are equivalent. Okay, but simplifying is not the only way to find equivalent fractions. Also, we can extend fractions. Then by extending is the opposite way. Then for example, we have the fraction 5 over 2, and we have to we want to multiply each part, the numerator by 2 and the denominator by 2, and the fraction answer is going to be 5 times 2 is 10 at the top, and 2 times 2 at the bottom is 4. Then 5 over 2 is equals to 10 over 4. In here is not by simplification or by simplifying, is by extending the fraction. Simplifying means divide numerator and denominator by the same number, and extending the fraction or fractions means multiply the numerator and the denominator by the same number. Is the ways to find equivalent fractions. Guys, thank you so much. Bye bye.